In this video, we will give information and a logical explanation why and how idiopathic adolescent scoliosis develops and how it can be with elementary change. Cervicospinal point com represents scoliosis. How does the diagnosis lose its force? The key to its early detection and how surgery can be avoided. Scoliosis is a three-dimensional curvature of the spine which leads to a distortion of a person's posture. In scoliosis, a person's spine and chest change shape gradually, which gives the impression of disturbed symmetry of the body. There are several different types of scoliosis. 1. Infantile, 2. Juvenile, 3. Neuropathic, 4. Traumatic, 5. Degenerative, and others. Here we will focus only on juvenile idiopathic scoliosis, which visibly affects adolescents between 10 and 13 years and is 90% of all known forms of scoliosis. The measurement of scoliosis is done with the so-called scoliometer. The measurement of the chest is done with ordinary sewing meter. And the detection, development, and control of distortion is done by X-ray doctors, photos using the so-called cube angle. The larger this angle, the greater the curvature of the spine and chest, and the more severe the form of scoliosis. There are 3 stages of deformation which are determined by the size of the cube angle. 1. Angle below 20 degrees. 2. Angle between 20 and 40 degrees. 3. Angle more than 40 degrees. These angles determine relatively whether scoliosis is suitable for conservative treatment, whether it is developing, or whether surgery is necessary. How is scoliosis treated? Standard medicine has many different ways to treat scoliosis. If you look in detail, however, with the exception of surgery, all other methods according to modern analysis have a dubious effect. Scoliosis surgeries are one of the most difficult in orthopedics. What are the causes of idiopathic adolescent scoliosis? In first place is the person's upright posture, as the second is the shape of the chest. Third are changes in the shape of the heart and aorta. Fourth, connective tissue weakness such as Marfan syndrome or other genetic diseases. This disease occurs only in humans. Proof of this is that no other animal species has scoliosis. The reason for this is the different shape of the chest in humans and animals. In animals, the thorax is more elongated, and in humans, it is more rounded. But why is the shape of the chest so important for the development of scoliosis? How the shape of the chest determines the development of scoliosis, and especially how with relatively elementary means of behavior can change in most cases this. We will explain now. The thorax consists of thoracic vertebrae, sternum, and 12 pairs of ribs, which are located symmetrically on both sides of the spine. They are connected by joints. It houses important organs such as the heart and lungs. The chest has the function of stabilizing the spine. But let's take a closer look at the inside of the chest. As we said, there are 12 thoracic vertebrae. 10 of them are connected to the ribs with the sternum. Thus, the thorax is a relatively rigid structure in the body. Of particular importance for the development of scoliosis is the 7th, 8th, 9th thoracic vertebrae and especially the 8th thoracic vertebrae. On the side of the 8th thoracic vertebrae are the hemizygous vein on the left and the azygous vein on the right. The hemizygous vein on the left in most cases passes in front of the 8th thoracic vertebrae and flows into the vein azygos on the right side. That's how the venous fluid moves from the chest and abdomen upwards in the direction of the second right rib, where the azygous vein flows into the so-called superior vena cava. It in turn carries blood to the right half of the heart. Blood from the left half of the heart is pushed into the aorta, which is located next to and in front of the left side of the thoracic vertebrae and carries blood to the whole body. It is the largest blood vessel in the human body. The area of and around the thoracic vertebrae, the aorta, is located in front of the hemizygous vein. Thus, this vein, and especially the part of it that passes in front of the 8th thoracic vertebrae when the body is laying down, are compressed by the aorta, and so the blood stays in the area of this vein and its speed slows down. To understand how scoliosis develops, we must first explain how the blood supply and the growth of the thoracic vertebrae work. In the body of the vertebrae during pregnancy and early childhood up to 6 to 7 years exists a network of embryonic blood vessels. By this age, 3 more venous blood vessels develop, which transport blood from the vertebrae and spinal cord to the veins of the body. These 2 blood supply systems are interconnected and function as a whole for up to 6 to 7 years. Thus, blood stagnation in the vertebrae cannot occur. After this age, the embryonic blood vessels gradually disappear and the blood from the vertebrae is transported only by these 3 blood vessels. There are 2 growth cartilage plates, anterior and posterior, that grow symmetrically and merge gradually and eventually ossify, thus growing symmetrically with normal blood supply and vertebrae. This is important to explain the development of scoliosis. The development of scoliosis process goes through 3 successive stages. First stage, shaping a flat back. Second stage, of lateral distortion. Stage 3, development of scoliosis. It is the recognition of these 3 stages that is important to know and distinguish in order to take appropriate measures against the development of scoliosis in time. What is a flat back? How does it develop and why is it so important for the prevention of scoliosis? Normally, the spine has 3 physiological curves. In the neck and waist, these curves have concave shape and are called lordosis. In the thoracic region, the spine has a convex shape and is called kyphosis. When forming the flat back, the chest curve, so-called kyphosis, reduces its curvature and lengthens. How does the shape of the chest change with a flat back? Normally, a person's chest is shaped like a barrel. When the thoracic kyphosis is smooth, the thoracic spine lengthens and enters the inside of the chest. Thus, the chest with a flat back gradually acquires the shape of a bean. Here again, you can see from the side how the chest deforms and a flat back is formed. The reason for the formation of a flat back idiopathic adolescent scoliosis is the position on the back of the body on the back during sleep. Proof of this is that practically all children who for one reason or another are forced to be in a constant laying position develop a flat back and scoliosis, and almost all children who are not forced to sit on their backs during sleep do not develop scoliosis. But how exactly laying on your back causes the development of a flat back will be explained by looking closely at what happens in the chest when the body is on its back for a long time. Under the action of gravity in the area of the anterior side of the vertebrae, forces act with the opposite direction of stretching to the head and legs. Thus, the anterior cartilage growth plate develops more and faster than the posterior cartilage growth plate. Therefore, the anterior side of the vertebrae grows much more than the posterior side. The anterior-posterior corner of the vertebrae enlarges and the vertebrae gradually acquires a wedge shape. When the vertebrae changes its shape in this way, the thoracic spine during growth bends not as normally forward to form kyphosis, but backwards and thus develops a flat back. So the thoracic spine enters the thorax and a flat back is formed. See how flat back scoliosis develops and what happens in the chest when the thoracic vertebrae move inward into the chest as in the flat back. As we have already explained, next to the vertebrae are the vein azygos and hemiazygos. In front of the vertebrae is the heart. The aorta is located between the lateral surface of the vertebrae, the heart and ribs, and the vein hemiazygos. After 6 to 7 years, the venous blood from the vertebrae drains only through these two blood vessels into the azygos vein and the hemiazygos vein on both sides. When this drainage system works properly, then the growth cartilage plates grow symmetrically and ossify and no scoliosis develops. In heart-involved defects and diseases of the aorta and connective tissue, the heart and aorta enlarge and compress vein hemiazygosity. Therefore, the blood from the vertebrae cannot drain properly. It stagnates in it. Current compression and stagnation of blood also occurs when the vertebrae enter the chest, as in the case of a flat back with force lying on the back or already developed scoliosis. The posterior cartilaginous growth plate, which is closest to the hemiazygos vein, slows down or stops its growth due to venous stasis. Thus, the left posterior half of the vertebrae and the adjacent ribs remain smaller. Back the right half of the vertebrae and the ribs continue to grow normally. And so, the chest is deformed with the formation of a rib hump and right-sided scoliosis. The normal development of children after birth goes through 3 growth phases with accelerated growth. The first phase is about 3 to 4 years, the second about 6 to 7 years, and the last one about 10 to 11 years. Decisive for the early detection of the development of scoliosis is the phase with accelerated growth between 6 and 7 years. It is at this age that active action for the early detection and treatment of idiopathic adolescent scoliosis should begin. The growth of children is a process that is associated with the gradual ossification of the cartilage of the vertebrae and bones of the body. With an already developed skeleton, as in adults, the correction of already occurred bone deformities without surgery is a long and difficult process. Therefore, action must be taken against this in time. The moment of development of a flat back in children in the phase of accelerated growth between 6 and 9 years is associated with a very rapid and a short time growth in height by more than 5 centimeters. This is omitted as a sign of early recognition by pediatricians and orthopedists. This is the moment that precedes the next stage in the development of scoliosis. Here, hardening of the spine develops in this area where the problem with the impaired blood supply to the vertebrae began. This hardening is a harbinger of lateral curvature of the spine and chest and then the development of scoliosis. Only in the phase of development of a flat back can scoliosis be stopped, slowed down, or regressed with active actions. And the solution is simple. It is a change in body position for a long enough period of time from back to the side or belly. Thus, the process of development of idiopathic adolescent scoliosis is explained without missing the smallest details. Therefore, the shocking diagnosis of scoliosis loses its force.